Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to learn algebra. Today is our lesson number 50. Lesson number 50. Day number 50. Excuse me. Today happens to be the last day where we are going to cover the topic of how to add and subtract algebraic expressions. In the first 20 days of the course, we learned how to evaluate algebraic expressions. For the next 30 days, from 21 through 50, we have been learning how to add and subtract algebraic expressions. Today is our last day, as I said. Starting from tomorrow, we're going to learn how to multiply and divide algebraic expression. As it stands right now, I think it might take me 20 days, it might take me 30 days, we'll see. It's just a tentative schedule here. So let's get going. Enough of the talk. So problem for today is, as we said, we are learning how to add and subtract algebraic expressions. We are asked to subtract 4/3, or rather 3/4 y cubed minus 2/9 y squared from 1/3 y cubed minus 1/3 y squared. First thing first, as I always explain to you in the beginning of each lesson, just to remind you, just to drill it in there, that when you're subtracting algebraic expressions, it's just like subtracting numerical values. If somebody asks us to subtract 7 from 13, subtract 7 from 13, even though 13 appears towards the end of the sentence, we know that 13 goes first. We have to subtract 7 from 13. The quantity that is being subtracted from has to go on the top. This quantity that is being subtracted goes on the bottom, even though it is mentioned first. It is mentioned first. Subtract this quantity from this quantity. This is a quantity. This is a numerical value. All of this is a numerical value. It has some numerical values. The only problem is that we do not know what y is. Had we been told the value of y, had we been told how much y is, we would have been able to actually evaluate the value of these expressions, like we did in the first 20 days there. That's what we learned in the first 20 days, how to evaluate values of algebraic expressions when the values of the variables are known. If you're told how much is x, how much is y, how much is z, if we know the values of the variables, individual variables that appear in the expressions, we can plug in their values and evaluate the value of the entire expressions. But we do not, alas, we do not know the value of y, so it's going to remain like that. But it is a numerical number, it is a numerical quantity rather. So therefore this is going to go first, just like this one here, 13 goes first. This is going to go first, and then from that we're going to subtract the top quantity. So here we go, 1/3 y cubed minus 1/3 y squared, and then 3/4 y cubed minus 2/9 y squared. This has a positive sign in front of it, this has a positive sign in front of it. First thing first. Well, first thing is that we have to line up the like term first, which we already have done it, which was actually done for us. Y cubed are lined up and y squared are lined up. The second step is to make sure that we can change the signs of each of the coefficient of the expression that is being subtracted. The expression that is being subtracted is this bottom expression. So we have to go through the coefficient of all of these and convert the sign. This positive will become negative, and this negative will become positive. But do not get rid of this negative sign to begin with. Some people have a nasty habit of simply, if they see a negative, they just go like that. Don't do that. Leave the negative the way it is and show that it is being converted into positive, like that. That is the standard notation. If it is positive, leave the positive, don't scrim it out and put a negative on top of it. Leave the positive the way it is, and underneath it show that it is being changed into negative, just like we did here. Do you understand? This is the proper way. If you're going to do something, do it properly. Doing like this, if it is negative, for example like here, this is negative, and if you simply change that into positive, that's what I would call cutting corners. Do not cut corners. Do quality work. If it's negative, show that it is being changed into positive. So the reader can see that it was negative to begin with, and then it was changed to positive. As opposed to taking a negative and put it right here. I cannot tell what happened. I cannot tell what was it originally, what happened to it. It looks to me that it was positive to begin with. Well, it wasn't a positive to begin with. It was negative quantity, and since we are subtracting it, it changes into positive. Okay? Enough of that. Let's do the work on the bottom. So now, rather on the top. Now all we have to do is simply add up the coefficients. I need the room, so I'm going to erase the top. We no longer need the top part. Let's add up the coefficients. So here we have positive 1/3, positive 1/3, and from that we are subtracting positive 3/4. As you can see, we have a positive 1/3, and from that we are asked to subtract. We had a positive 1/3, and we were asked to subtract from that. We were asked to subtract from this quantity. We are asked to subtract this quantity. We are asked to subtract this quantity, and therefore negative times positive will become negative, which is what we're showing here. That this positive 3/4 will become negative 3/4. So what this is actually is, what this boils down to is 1/3 minus 3/4, which is what we're showing here, that this positive becomes negative. So let's do it then. We need a common denominator. What is the common denominator of 3 and 12? 3 and 4? Well, the answer is 12. How do we convert this 3 into a 12? Multiply the top and the bottom of this fraction by 4. How do we convert this bottom fraction, this denominator into 12? Multiply the top and bottom of this fraction by 3. By not 3, but rather 3 over 3. Not 4, but 4 over 4 is what I meant to say. Because if you multiply it by 4 over 4, you're in essence multiplying it by 1. And when you multiply anything by 1, it doesn't affect the original value. It's going to remain there. 17 multiplied by 1 is going to remain 17. If I have 17, if I were to multiply that by 1, well, it's still 17. I just multiplied by 1, even though this quantity does not look like 1, it's 1. 33 over 33 is 1. It's 1 incognito, in disguise. Incognito was the word I just used. Let's keep going. So now we have the denominator of 12 here, denominator of 12 here. We have a common denominator of 12. We simply have to go 4 times 1, which is 4. Negative times positive is negative, and 3 times 3 is 9. 4 minus a 9 is going to give us negative 5, 12. Negative 5, 12 is the coefficient of y cubed. Negative 5, 12, y cubed. Now we have to find out the coefficient of y squared. Let's do it again on the top. We need the room, so we need to get rid of this thing. We have negative 1/3, negative 1/3, negative 1/3, minus a negative 2/9. And again, you can see that as soon as we open the parentheses, this negative times negative is going to become positive, which is what we've been showing here. Negative becomes positive, you see? We need the common denominator. This is 9, this is 3. Let's multiply this by top and bottom by 3. So we have the common denominator of 9 now. And this is just 3 times 1, which is negative 3, because it's a negative here. And negative times negative is positive, and that's 2. Negative 3 and a positive 2, it gives us negative 1. So it's just negative 1/9 y squared. That's it. That's our answer. That's our answer. Negative 1/9 y squared. And we have finally arrived. It took us a long time. When I started out this thing, I thought I was going to take 10 days to do to cover the topic of adding and subtracting algebraic expressions. The 10 days turned into 20 days, and 20 days turned into 30 days. But I wanted to make sure that I did every single problem that I had put together. I didn't want to skip anything, and I also did not want to water it down. If you do all the videos in its proper sequence, day 1 through whenever it ends, in all the videos in its proper sequence without skipping anything, and if you do all the problems with me, you will learn algebra the way it should be learned. You will have a solid foundation of the elementary concepts of algebra, which is what the goal is. I will see you tomorrow, where we will start a new topic of how to multiply and divide algebraic expressions. Alright? I'll see you tomorrow. Day number 51. Alright? Thanks. Bye.